9,000. That is how many targets the United States military has struck inside Iran since February 28th. 3 carrier strike groups, 8 Aegis destroyers. $50 billion of combined naval and air firepower deployed simultaneously across the Arabian Sea, the Red Sea, and the Persian Gulf. The results are measurable. Iran's surface fleet is gone. 140 warships destroyed. Ballistic missile launches down 90%. Drone attacks down 83%. And yet on day 3 of Operation Epic Fury, Iran's ballistic missile factories were still standing. The underground bunkers housing Iran's most dangerous weapons, buried 30 meters, 60 meters, 80 meters beneath reinforced concrete, were untouched. The carrier jets flew sortie after sortie. The Tomahawks hit their coordinates, and the hardened targets did not move. Why? Because the most powerful carrier air wings in human history cannot deliver a bomb heavy enough to reach what Iran buried underground. Every F/A-18E, every F-35C on those flight decks is limited to 2,000-pound munitions at combat range. And 2,000 pounds of steel and explosive does not penetrate 30 meters of reinforced concrete. It scratches it. So the Pentagon picked up the phone, not to call another carrier, not to order another destroyer. They called a bomber, specifically a bomber that first flew in 1952, a design so old it was conceived before the Soviet Union built its first hydrogen bomb. An aircraft that top Pentagon officials spent a decade trying to replace, right up until the moment it became the only thing in the inventory that could finish what 3 carriers started. Subscribe to Navy Brief. We do not cover the war. Neither we cover the math behind it, and this equation is one of the most counterintuitive we have ever run. Drop B-52 in the comments if the math changes how you see this war. To understand why a carrier air wing cannot solve a problem that a Cold War bomber solves in its first sortie, we first need to understand what Iran built underground and why it became the decisive variable of this war. Iran's military planners are not strategically naive. They watched the Gulf War. They watched Iraq 2003. They watched Libya 2011. They absorbed one lesson from every American air campaign of the last 35 years. Anything above ground gets destroyed. Radar installations, missile batteries, command centers, airfields. If it can be seen from orbit, it can be hit. Iran's response was to go underground. Since the late 1990s, Iran systematically relocated its most critical military infrastructure beneath the earth. Ballistic missile production facilities, centrifuge halls, enrichment cascades, command and control nodes, engineering and design centers. Iran did not just dig bunkers. They engineered hardened underground complexes, reinforced with multiple layers of concrete, designed to absorb a direct hit from a 2,000-pound bomb and continue operating. Some facilities sit 80 meters beneath the surface. That is the height of a 25-story building inverted into the earth. Now run the geometry of the problem. A 2,000-pound JDAM, the standard precision-guided bomb carried by every aircraft on a carrier flight deck, penetrates approximately 6 feet of reinforced concrete before stopping. 6 feet. The facility underneath sits at 260 feet. The math does not work. You are not destroying the target. You are announcing your arrival. This is not a flaw in planning. This is a deliberate Iranian calculation. They studied the weapons. They measured the penetration depths. They dug precisely deep enough that carrier aviation, the most powerful tactical air force afloat, becomes irrelevant to the mission. Iran did not build a military. They built a military specifically designed to survive the only air force America routinely brings to a fight, until America brought the other one. The carrier is the apex of naval power projection. Nothing in human history comes close, but it is engineered for a specific kind of war. Precision strikes against surface targets, suppression of enemy air defenses, close air support, maritime interdiction. Every aircraft on a carrier flight deck is optimized for the same physical constraint. It has to land back on a 1,092-foot runway moving through the ocean at 30 knots. That constraint shapes everything: wing loading, fuel capacity, and most critically, ordnance payload. Let us look at the math. The F/A-18E Super Hornet carries a maximum external payload of 17,750 pounds. In combat configuration, accounting for fuel tanks, targeting pods, and air-to-air missiles for self-defense, that payload drops to 8,000 to 10,000 pounds of bombs. The heaviest single weapon it can carry is the 2,000-pound GBU-31 JDAM. That is the ceiling, 2,000 pounds. The F-35C is worse on payload. Its stealth depends on carrying weapons internally. The internal bay holds 2 GBU-31s. To carry anything heavier, it goes external. Going external means the radar cross-section expands, and the stealth advantage that justifies its $100 million price tag disappears. A $100 million stealth fighter carrying a 2,000-pound bomb it was not designed to carry, against a target 260 feet underground, The numbers do not add up. Now add the distance problem. Lincoln operates in the Arabian Sea, 500 nautical miles from Hormuz. An F/A-18E at combat loadout burns fuel at a rate that leaves it approximately 40 minutes over the target before it has to turn back. 40 minutes. Enough for one strike package, not enough for the sequential, assessed, follow-on strikes that hardened underground facilities require. The Tomahawk cruise missile carries a 1,000-pound warhead. Range, 1,000 nautical miles. Precision, within feet. Against a soft target. A radar site, a fuel depot, a command building above ground. The Tomahawk is lethal and cost-effective at $2 million per shot. Against 80 meters of reinforced earth and concrete, a Tomahawk is very expensive noise. The warhead detonates on the surface. The facility 260 feet below never feels it. So, the carrier jets bring too little weight. The Tomahawk brings too little penetration. And both operate at maximum range against a target set engineered to absorb exactly what they can deliver. That is not a list of bad weapons. That is a pattern. And the pattern points to something deeper. Every weapon in the carrier strike group's arsenal is designed for targets that exist above the surface, in the air, or on the water. Iran's most critical infrastructure exists below all of it. The Navy brought precision to a depth problem, and depth does not care about precision. Here, the shotgun already existed. The Pentagon just had to find it in a hangar full of aircraft they had been trying to retire. The Boeing B-52 Stratofortress first flew on April 15, 1952. Its designers were solving a problem that had nothing to do with Iran. How do you deliver a nuclear weapon to a target inside the Soviet Union from bases in the continental United States? The answer was simple. Build the largest possible aircraft carrying the largest possible bomb over the longest possible range. 73 years later, that solution is still flying. And at Hormuz, it became the only solution that worked. Start with the payload. The B-52H carries a maximum ordnance load of 70,000 pounds. Not 17,750. 70,000. 4 times the maximum payload of an F/A-18E on a single aircraft. Yet a conventional rotary launcher in the internal bomb bay holds 8 weapons simultaneously. External pylons carry an additional 35,000 pounds across 6 wing stations. In a single sortie, one B-52 delivers what would require 4 full carrier strike packages to match, if the carrier packages carried the right weapons. They do not. For the hardened underground problem at Hormuz, the relevant weapon is the GBU-28 bunker buster. 5,000 pounds, 4 feet in diameter, 19 feet long. A laser-guided steel penetrator packed with 630 pounds of tritonal explosive, fitted with a delayed fuse designed to detonate only after the weapon has already punched through 100 feet of earth or 20 feet of reinforced concrete. One aircraft carries multiple GBU-28s simultaneously. Yet the same aircraft that cannot fit on a carrier deck carries more bunker busters in one sortie than a carrier air wing can deliver in a day. Run the math. A carrier air wing of 44 aircraft flies 100 sorties per day. Each F/A-18 delivers one 2,000-pound JDAM per pass against a hardened target. That is 200,000 pounds of steel arriving at the surface of a complex that requires 5,000-pound penetrators to breach. 0 of those strikes reach the facility. One B-52, delivering 4 GBU-28s, delivers 20,000 pounds of precisely the right weapon to precisely the right depth. Not a marginal improvement, a categorical difference in what gets destroyed. Now add the range. The B-52H has an unrefueled combat range of 8,800 miles. Diego Garcia, the US-UK base in the British Indian Ocean Territory, sits approximately 2,500 miles from the Strait of Hormuz. A B-52, launching from Diego Garcia, reaches Iranian airspace with fuel to loiter, strike, and return without a single tanker. And with aerial refueling, a routine operation B-52 cruise train for constantly, the operational range becomes unlimited. The aircraft can orbit international airspace for 10 hours, assess damage from prior strikes in real time, and deliver follow-on weapons against the same target in the same sortie. But the range advantage goes deeper than distance. The B-52 carries the AGM-158B Joint Air-to-Surface Standoff Missile Extended Range. The JASSMER range, 575 miles. The B-52 never enters Iranian airspace. It never comes within range of Iran's surface-to-air missile batteries. It flies in international airspace, 575 miles from the target, and releases weapons that navigate autonomously at low altitude through terrain following flight profiles to strike coordinates accurate to within feet. From Iran's perspective, the B-52 is invisible until the cruise missiles are already inbound. By then, the aircraft is already turning for home. Compare that physics to the carrier strike. An F-A-18 must penetrate Iranian airspace to drop a JDAM. It faces surface-to-air missiles, man-portable systems, and radar-guided anti-aircraft guns for every minute of the ingress, the strike run, and the egress. The pilot is inside the threat envelope for 20 to 30 minutes per sortie. The B-52 crew is never in the threat envelope at all. Distance is the armor. Range is the countermeasure. That is not a coincidence of design. That is the same physics principle the aircraft was built around in 1952. In the opening 72 hours of Operation Epic Fury, B-52s operating from Diego Garcia flew the longest-range strike missions of the campaign. Their targets were not ships, not radar installations, not command nodes. Those targets the carriers handled brilliantly, with Tomahawks and strike packages. The B-52s went after what the carriers could not reach: ballistic missile production facilities buried beneath reinforced mountain tunnels along Iran's interior, underground centrifuge complexes that had survived 3 decades of sanctions, 4 rounds of nuclear negotiations, and 2 decades of diplomatic pressure without a scratch, hardened command bunkers designed to remain operational after a near miss from a nuclear weapon. One of these were the targets CENTCOM needed destroyed to stop Iran from reconstituting its long-range strike capacity after the surface campaign ended. For the first time since Operation Desert Storm, B-52s flew strike missions against hardened underground facilities in an active combat theater using penetrating munitions at operational scale. Not a single carrier jet flew those missions. Not because the carrier pilots are not skilled enough, they are the best in the world. Because the aircraft they fly cannot carry the weapons the targets required. The results are measurable. In the first 72 hours of Epic Fury, Iranian ballistic missile launches dropped from sustained coordinated salvos to isolated singles. By day 5, large-scale coordinated ballistic missile attacks had stopped entirely. Not because Iran ran out of missiles in storage, each because the facilities that produced replacement missiles, stored launch sequences, and coordinated targeting were no longer operational. No carrier aircraft did that. No Tomahawk did that. The B-52 did that. There is a second problem the carriers could not solve that receives almost no coverage in the analysis of this war: battle damage assessment. You strike a hardened underground facility. You need to know if the target is destroyed, damaged, or essentially untouched. If damaged but intact, you need to restrike. With different fusing, different approach angle, different weapon, you need time over the target to assess and re-engage while the picture is still current. An FA-18 has 40 minutes over the target area. By the time it delivers its weapon, pulls off the target, assesses the impact, and positions for a second pass, and it is already at bingo fuel. It has to leave. The second strike requires returning to the carrier, landing, rearming, taking off again, and flying 500 nautical miles back to the target. 90 minutes. In those 90 minutes, Iran moves mobile equipment, repositions personnel, begins damage control, seals blast doors. The operational picture the first pilot saw no longer exists when the second one arrives. The B-52 does not have this problem. A single B-52 with aerial refueling support can orbit a target area for 10 hours. It strikes. It watches the result. It adjusts. It re-engages with a different weapon from a different angle against a different aiming point identified during the first pass. All of this without leaving the target area, without the 90-minute gap, without giving Iran time to adapt. The B-52 is not just a delivery vehicle, it is a persistent strike platform that learns about the target while it is still watching it. There is one more element the payload numbers alone do not capture. The B-52 can be retasked in flight. A carrier strike package is planned 18 hours in advance, briefed to the aircrew committed at launch. Changing the target mid-mission is possible but complex, time-consuming, and requires re-coordination across the entire strike package. A B-52 crew with JASSMERs already aboard and a direct encrypted data link to CENTCOM can receive updated target coordinates, reprogram weapon guidance packages, and strike a new location while still airborne. In a target environment where Iran is constantly moving mobile ballistic missile launchers to new positions, a lesson Iran learned from watching how the US hunted Scud launchers in Iraq, That flexibility is the difference between destroying a launcher and photographing an empty road where one used to be. Iran's air defense architecture was designed for one specific threat: tactical aircraft operating from carriers and regional bases. They spent 4 decades and billions of dollars mapping the radar signatures, approach corridors, and weapons envelopes of every aircraft in the American carrier air wing. They built layered surface-to-air missile networks, SA-6, SA-15, Bavar 373, calibrated precisely to the ingress profiles of FA-18S and F-35S. They calculated the maximum penetration depth of 2,000-pound JDAM variants and dug their facilities exactly deep enough to survive them. They did not calibrate for 5,000-pound penetrating munitions. They did not build countermeasures for cruise missiles launched from 575 miles away by an aircraft that never enters their airspace. They did not design their integrated air defense network to detect or engage a threat that never requires a targeting solution because it never comes within range. Iran built a perfect defense against carrier aviation. And carrier aviation was not what finished the job. This is the pattern that runs through every equation in this war. Iran studied the American military deeply, accurately, and specifically. They knew exactly which weapons the carriers carried. They measured their bunker depths against 2,000-pound warheads because that was the heaviest weapon carrier aviation could deliver. They calculated correctly. They were right about carrier aviation. They were right about the Tomahawk. They were right about every weapon in the carrier strike group's arsenal. But they measured against the wrong variable. The carrier is not the American military. It is one tool in an inventory that includes a 70-year-old bomber capable of carrying weapons the carrier cannot lift, from distances the carrier's aircraft cannot reach, against targets the carrier's pilots cannot destroy, without ever crossing into the airspace Iran spent 40 years fortifying. Iran built its entire underground infrastructure program to survive carrier aviation. It survived carrier aviation perfectly. So and then, the B-52 arrived from Diego Garcia carrying weapons Iran's architects never included in their penetration calculations. The equation changes when the variables change. Iran locked their equation to one variable. America changed it. The underground facilities that took decades to build became accessible in hours. They solved the right equation. But it was the wrong variable. The B-52 will eventually retire. The B-21 Raider exists precisely to inherit this mission with stealth instead of standoff range, low observable instead of long legs. But the B-21 is not yet operational in the numbers this campaign required. And Hormuz did not wait for the B-21. It waited for what was already in the inventory, already paid for, already crewed by pilots and weapon systems officers who had trained for exactly this mission for their entire careers. An aircraft that top Pentagon officials spent a decade calling obsolete, redundant, and ready for the boneyard, right up until the moment it was the only platform in the American inventory capable of reaching 80 meters underground and delivering enough steel to matter. 3 carrier strike groups fought the war that tactical aviation is built to fight. They fought it brilliantly. 140 ships destroyed, 9,000 targets struck. The surface fleet of Iran ceased to exist as a coherent fighting force. The carriers did their job. They did it at a level that no other navy on Earth could replicate. And then the war needed something different, something heavier, something with more reach. And something that could go to depths carrier aviation was never engineered to touch. The Pentagon did not develop a new weapon. They did not build an emergency program. They picked up the phone and called the aircraft they had been flying since Eisenhower was president. We do not worship the machine. We worship the equation. And the equation says this: 3 carriers brought the most powerful tactical air force afloat. 17,750 pounds of payload, 40 minutes over target, 2,000-pound warheads against 260-foot depths. The B-52 brought 70,000 pounds, 10 hours over target. GBU, 28 penetrators against the same 260 feet. The math at every point favored one aircraft, and it was not the one on the carrier flight deck. A good engineer does not use the most advanced tool. A good engineer uses the right tool. The right tool for Hormuz was the oldest one in the fleet. Navy brief. We do not cover the war, we cover the math behind it. Drop B-52 in the comments if this changed how you see what a carrier can and cannot do.